In this next module, we're going to talk about diagnostic testing using as an example that cellulite DX test that I set out as the teaser in the opener this week. So when we're talking about diagnostic testing, we're talking about things like sensitivity, specificity, positive predictive value, and negative predictive value. I've already used these terms a little bit this week. Now I'm going to formally define them, and we're going to do a little bit formal calculation of them. So first of all, the sensitivity is the probability that if you truly have the disease, that the diagnostic test is going to catch it. How sensitive is the test? Specificity is the probability that if you don't have the disease, that the test is going to accurately register as a negative. You want both of those to be good. Positive predictive value is the probability that if you test positive for the disease, you actually have the disease. This is usually what the patients are more interested in, right? If you have a positive test, what's the chance that you actually have the disease? We calculated this already today for a couple of conditions. Similarly, the negative predictive value is the probability that if you test negative for a disease, it's the probability that you actually do not have the disease. Now, unlike sensitivity and specificity, which actually don't depend on the prevalence of a disease, that only depend on how good the test is, the positive predictive value and negative predictive value depend directly on the prevalence of the disease, of course, as well as how accurate the test is. So let's get back to this fun example, the cellulite DX test. Again, I put the link here if you're curious about going to the company's actual website. So this is a test that the company sells for about $250 a pop. It's a genetic test to tell women whether or not they are likely to develop moderate to severe cellulite. So the idea is that a young woman might take this test before she develops cellulite, and it would give her some information about whether or not she's likely to develop cellulite, and therefore she and her doctor might be able to do something together to mitigate her risk. So here's the pitch the company has on its website for this test. They say a patient who tests positive has approximately a 70% chance of developing moderate to severe cellulite. Notice that's the positive predictive value. A patient who tests negative has approximately a 50% chance of not developing moderate to severe cellulite. So that's the negative predictive value. Now, if you're thinking about this carefully, right away you can see that this test is not terribly useful, right? So if you test positive, you have a 70% chance of developing moderate to severe cellulite, approximately. If you test negative, notice you still have a 50% chance of getting moderate to severe cellulite, right? It's not terribly different. 1 minus 50% is 50%. So if you test positive, it's a 70% chance. If you test negative, it's still a 50% chance. So right away, you kind of see this, is this really that useful, even assuming that there's something you can do to intervene and prevent the onset of cellulite. But it gets even funnier than this, okay? So we're going to delve into this a little bit more deeply into the numbers. It's a great illustration of diagnostic testing, and the numbers come out to be even funnier than this. So first of all, where did this test come from? So the Cellulite DX test was developed based on a case control study, where researchers were looking at a particular genetic variant, and they were able to show that this genetic variant was statistically associated with moderate to severe cellulite. So it was a case control study. Here's the data from that study. They sampled 200 cases. These are women who have moderate to severe cellulite, and 200 controls, women who did not have moderate to severe cellulite. And then they tested them for this particular genotype. And if you carried a D allele, that was associated with a significantly higher risk of having moderate to severe cellulite in this case control study. Here are the numbers. So when you get a positive on the Cellulite DX test, all that means is that you carry a D allele. So so again, this same numbers are used for if you have a positive on the Cellulite DX test, that's the same as having this genetic allele. So now let's look at the test and who actually has the disease, and right from this 2x2 table we can calculate from these data sensitivity and specificity. And a lot of times when you're calculating sensitivity and specificity from actual data, you might setting it up in a 2x2 table like this. We can also calculate this from a tree and all those other things we've learned, but let's do it from a 2x2 table now. So what's the sensitivity here? So there are 200 women who truly have cellulite. Out of those women, those are the case women, 168 of them tested positive on this test. So that would make the sensitivity 84%. Notice that there were 32 women who falsely tested negative out of 200 cases. The specificity is 26%, because if you look carefully, there were 200 women who did not have cellulite. Only 52 of them actually tested negative on this test. So this genetic variant is actually really common. So it's much more common to get a positive result from this test than to get a negative test. But the specificity here was 26%. In other words, there were 148 false positives. 148 women out of the control group falsely tested positive on this test. So that's the sensitivity and specificity, and if you go to the company website, they have a nice little brochure where they lay out the calculation of sensitivity and specificity for you. They did it correctly. What's really fun about this problem is if I asked you to calculate the positive predictive value, it's actually a little bit tricky. So this is a really good exercise, I think, because if I just give you the data in the 2x2 table, when I give this to students and I say calculate the positive predictive value, everybody's tempted to say, oh, well, there were 316 people who tested positive, 168 of them actually have cellulite, so that's the positive predictive value. That is in fact incorrect, okay? So why is that not correct? Keep in mind the study design here. This is a case control study. So the prevalence of the condition of having moderate to severe cellulite is different in the study sample than it is in the general population. And remember, positive predictive value depends on the prevalence of disease. So we have to factor in the actual prevalence of the disease in the general population here in order to calculate positive predictive value for this test. So that's a little tricky. To the company's credit, if you go read their little brochure, they say, oh, well, they knew that they had to incorporate the actual prevalence. They must have had a statistician involved. So they say, oh, yeah, we used Bayes' rule to calculate it. So indeed, they used Bayes' rule to incorporate the true prevalence of cellulite in the population. So that's a great example of where Bayes' rule can be useful. So let's actually do this. Let's use Bayes' rule to calculate the positive predictive value, incorporating the true prevalence of cellulite in the population. So the company said that the true prevalence of moderate cellulite in women was 65%. That sounds reasonable to me, so we'll assume that that's reasonable. So now we can use Bayes' rule to incorporate that. Notice that that's higher than in the case control study where it's only 50%. So here's how we would apply Bayes' rule. We want to know the positive predictive value. We want to know the probability that you will get moderate to severe cellulite if you test positive on this test. Well, we can just apply Bayes' rule here. So that's going to be equal to the probability of testing positive, given that you actually are a woman who's going to get cellulite, times the marginal probability of getting cellulite, that's the prevalence in the population, over the marginal probability of testing positive at all. All right, so what's the probability that you're going to test positive given that you are positive? Well, that's the sensitivity of the test. We just saw that that was 84%. What's the marginal probability of having moderate to severe cellulite? The company just told us that that's 65% in the general population. So that's where we're incorporating that number. What's the marginal probability of testing positive? Well, there are two ways you can test positive. You can be one of those 65% of women who actually has moderate to severe cellulite or is going to get it, and your chance of testing positive is 84%, the sensitivity. Or you can be one of the 35% of women who is not destined to get moderate to severe cellulite. Your chance of testing positive on this test is actually 74%. That's 1 minus the specificity. Remember, the specificity was 26%. That means the false positive rate is 74%. So that's the marginal probability of testing positive. When you add that up, it comes out to be 0.805 in our denominator. So we can put all these numbers together. So 0.84 times 0.65, that's equal to 0.546. If we divide that by the denominator of 0.805, we get that the positive predictive value is 67.8%. All right, so the company calculated that in their literature. Now, in their marketing material, they rounded that up. So they said, "Whoa, the actual probability that you're going to get moderate to severe cellulite if you test positive is about 68%. Well, they said they rounded that up to approximately 70%. They're trying to boost it, make it look a little bit better. Okay. Now notice that that's an application of Bayes' rule. For those of you who are more comfortable using the tree, which most students are when they first start this material, you could also do this on the tree. So let me just quickly show you how to do it on the tree. And then I'm going to show you how to do it using a 2x2 table. I'm going to give you many ways to get the right answer. And remember, with probability, there's many ways to get the right answer. Some are more efficient than others. Some are better for when you're learning. So the first thing is you're either one of these women destined to get the cellulite or you're not. That's 65% prevalence, and 1 minus 65% is 35%. So that's whether or not you truly have the disease. Then you are either going to test positive on this cellulite DX test or not. If you actually have the disease, the sensitivity again is 84%, so your chance of not testing positive is 16%. If you don't have the disease, you still have a 74% chance of testing positive, and you have a 26% chance of not testing positive. We can multiply across the branches. So the upper branch is 0.546, this one is 0.104, this one is 0.259, this one is 0.091. I just got those by multiplying across the branches. Notice if I add all these up, it sums up to exactly 1, so I've done it right. So now, once I know that you've tested positive, then I know that you're either on this branch or you're on this branch. So once you know you tested positive, you're on one of those two branches. Which of those is actually having cellulite? Only the top branch. So the probability that you're actually going to get the disease, given that you tested positive in this case, will be 0.546 divided by 0.259 plus 0.546, and that again comes out to be 67.8%. So you can solve it this way if you're more comfortable still with the tree and Bayes rule. And I'm going to show you even one more way to solve it. So alternatively, we can use a little trick with 2x2 tables, and a lot of students find it easier to calculate it in this way. So if you're more comfortable with the 2x2 table, this is yet another way to get this right. So to solve for positive predictive and negative predictive value, you could incorporate the true prevalence by just doing a little 2x2 table and assuming that you have a denominator of 100 people. Why 100? Why am I picking 100 here? Well, it's easy to deal with percentages if you treat them as whole numbers. So if we start with 100 people, then all the percentages just become whole numbers. So for example, rather than talking about 65% and 35%, I can say if I had 100 women in the general population, 65 of them would have cellulite and 35 would not have cellulite, right? So I can set it out this way and make it super easy to do these calculations. Then you can apply the sensitivity and specificity to figure out how many of them are going to test positive and test negative. So for example, we start with the prevalence of the disease, and then we know out of the 65 women who have the disease, 84% of them are going to correctly test positive. So we can fill in that cell with a 55. Out of the 35 women who truly do not have the disease, only 26% of them, that's the specificity, are going to test negative. So we can fill in that cell with a 9 there. And then you can just subtract. Now we have enough information to be able to fill in the rest of the cells. So for example, 65 minus 55 is 10, 35 minus 9 will get us to 26, so we can fill in all of those cells. So now we have enough information with the correct prevalence of the disease in the population to calculate positive predictive value directly from the 2x2 table. And again, many students find it easier to do it this way because dealing with whole numbers is always easier than dealing with fractions and probabilities. So what will the positive predictive value be? There are 81 women who will test positive out of a sample of 100 women. Out of that, those 81, 55 of them will truly go on to get moderate to severe cellulite. So the positive predictive value here is 68%, the same 68% we calculated in two other ways. What's the negative predictive value? The negative predictive value we would calculate by recognizing that there are 19 women in the general population who will get a negative on this test. Of those 19, only 9 of them will go on to not get cellulite. 10 of them will actually go on to get cellulite. So the negative predictive value here is 47%. So 47% of those who test negative will not get cellulite. In other words, now remember that the company rounded that up to 50% when they reported it. So they said 50% of those who test negative will not get cellulite. So they're doing a little rounding again in their favor to make it look more interesting. In other words, though, another way to say it, rather than putting it negative predictive value, which is probably a little bit more difficult for most people to understand, the better way to say it would be that 53% will get cellulite. So in other words, if you test negative for this test, you still have a 53% chance of going on to get cellulite. So just to summarize here, if you don't take the test, your chance of getting moderate to severe cellulite is 65%, right? Because that's the prevalence, the risk of the disease in the general population. So if you don't take the test, you have 65% chance. Let's say you take the test. If you take the test, 4 out of 5 women who take the test are actually going to test positive. And if you take the test and you find out you're positive, your risk moves from 65%, just barely a little bit, to 68%. So most women are going to find out that their risk moved up just a tiny 3%. 1 out of the 5 women will test negative because this is just has to do with the prevalence of the particular genetic variant. It's pretty rare. If you test negative, then your risk goes down from 65% down to 53%. So it moves slightly more, down 12%, but still is not that different than just your risk to begin with, your prior probability. It's not changed that much. So our conclusion would be then that the test is basically useless. It barely moves your probability from just what your prior probability, your starting probability was. And most women are going to get test positive and their prior probability basically doesn't change at all. So it's not the most useful test in the world, but it's a really fun example for illustrating diagnostic testing and Bayes' rule. And just to conclude this module, again, sensitivity and specificity don't depend on the prevalence of the disease, but positive predictive value and negative predictive value do depend on the prevalence, so make sure that you're always incorporating that correctly as we did in the example today. And finally, this genetic variant was significantly associated with cellulite. There was a significant association there. You can see from the example today, though, that that doesn't mean, just because something is significantly associated, that doesn't mean that it's going to make a useful screening test. So always keep that in mind.